So let me think where I would even start. One great example that we've been working on is heart disease. So atherosclerosis is, of course, the number one killer in the Western world. It's the cause of heart attacks and strokes, and it's age-related because it's caused by the lifelong accumulation of a particular type of damage. In this case, the type of damage is the accumulation of waste products in the artery wall. The waste that matters here the most is oxidized cholesterol. Cholesterol itself is not a bad molecule. People get this wrong a lot, but cholesterol is a vital molecule. You don't want to remove your cholesterol. You do want to, however, remove the contaminated cholesterol that accumulates at low but significant levels in the body, oxidized cholesterol in particular. This is what poisons white blood cells that are in the artery wall and makes them into what are called foam cells, which are the first step in the creation of an atherosclerotic plaque. And we'd like to stop that happening, and we'd like to prevent atherosclerosis from emerging. So the way we've done this is we've identified bacteria in the soil, actually, that had genes and enzymes that allow them to break down oxidized cholesterol. And we've identified these bacteria and the genes and enzymes, and we've introduced those genes into human cells in cell culture. And it works. We have shown that these cells that have our engineered gene are much more protected. They're much more robust in the presence of a certain amount of this toxic oxidized cholesterol than cells that don't have it. And, of course, we're moving forward to take that to other types of cell and to mice before we go into clinical trials. That's the kind of thing that we're doing that's earlier stage, so it might take a bit longer.
This oxidized cholesterol, can this be eliminated with diet?
Absolutely not. The fundamental problem is that these molecules, these oxidized cholesterol species, they get into our white blood cells, they get into a part of the cell called the lysosome. They poison the cell, they inactivate the lysosome. And that means that these white blood cells can no longer do what they used to be able to do. They can no longer process normal cholesterol. No, you can't do anything to the diet. The stuff is just there because the cells don't have any machinery to get rid of it.
But are they a product of what we eat?
A product, but an accidental product. So they happen just because they're bound to happen.
But cholesterol comes from animal protein, is that mostly?
Kind of. We bring in cholesterol in our diet, and we also synthesize our own cholesterol in the liver. And that's how it should be. That cholesterol is doing a good job. The problem is that oxidation is a chemical reaction that is going to happen in the body, whether you like it or not. The fact is we are aerobic organisms. We need to breathe. We need to inhale oxygen in order to keep going. And breathing is really bad for you.
Breathing is bad for you?
Yeah. Breathing is why we get free radicals. But it's a bit non-negotiable. This is the thing. So we've got to intervene in this process one step down the chain of events to get rid of the toxic products of breathing rather than to get rid of breathing itself.
Breathing is bad for you?
That's a pretty straightforward statement, and it's unequivocal.
Wow. So when they use like hyperbaric chambers, oxygen-rich environments to enhance healing, is that extra bad for you?
Not necessarily. So, of course, breathing is also good for you. If you don't breathe, then you're totally screwed, right? So it's a trade-off. It's just that there are some aspects of breathing that are bad for you, and we need to fix those aspects.
And those aspects have zero to do with diet. So this
I wouldn't
type of cholesterol.
I wouldn't say zero. So if you're really low on, for example, vitamin C or vitamin E, then you are depleting your own body's ability to limit the toxicity of breathing. And therefore, that breathing will be even more bad for you than it otherwise would be.
So antioxidants are crucial if you're going to bother breathing.
Up to a point. But it turns out that because breathing has been around a long time, breathing was invented about 2 billion years ago, evolution has done what evolution tends to do. It's made the best of a bad job. And therefore, at this point, some of the toxic byproducts of breathing, free radicals, are actually not just bad molecules, they're also good. They're used by the body as signaling molecules. So if we were to have some magic wand that we could wave and just get rid of all the free radicals in the body, that would be extremely bad. You'd die at once. We have, therefore, a rather interesting balance that the body takes. If you have too few antioxidants, then that's bad news. But if you have an abundance of antioxidants, if you take mega doses of vitamin C or vitamin E, for example, it doesn't really do much. The reason it doesn't is because the body wants a certain amount of free radicals around, so it dials down the inbuilt antioxidant machinery, and you end up basically where you started.